Hi everyone, this is lesson 5-7, solving quadratic inequalities. The objectives for this lesson, you're going to be able to solve quadratic inequalities by using tables and graphs. You're also going to be able to solve quadratic inequalities by using algebra. Your vocabulary for today will be quadratic inequality in two variables. Many business profits can be modeled by quadratic functions. To ensure that the profit is above a certain level, financial planners may need to graph and solve quadratic inequalities. A quadratic inequality in two variables can be written in one of the following forms where a, b, and c are real numbers and a is not equal to 0. Its solution set is a set of ordered pairs x, y. Here you see some situations that would be inequalities. You can see y could be less than ax squared plus bx plus c, or y could be greater than that. Y could also be less than or equal to ax squared plus bx plus c, or y could be greater than or equal to. In lesson 2.5, you solved linear inequalities in two variables by graphing, and you can use similar procedure to graph quadratic inequalities. So what we're going to do is to graph quadratic inequalities. We're going to graph the parabola that defines the boundary, and then we're going to use a solid parabola for y is less than or equal to and y is greater than or equal to, and a dashed parabola for y is less than and y is greater than. So just like before, if it's a solid line, that means it's equal to, and if it's not equal to, it's going to be a dashed line. And then we're going to shade above the parabola if y is greater than and equal to, or we'll shade below the parabola. All right, in this example, we're going to be graphing quadratic inequalities in two variables. All right, so the first thing that we want to do is go ahead and we're going to graph the boundary of the related parabola. So I'm going to go ahead and set it to equal though. But I do know that it's going to be a solid curve because this says greater than or equal to, just like we did with the linear. All right. The first thing we could do is find the y-intercept, which is 10. All right, so remember the y-intercept says, what is y when x is 0? All right, so when x is 0, 0 minus 0 plus 10, so y is equal to 10. All right, so my y-intercept is at 0, 10. We can also find the vertex. Now remember how to find the vertex in a problem like this. To find the vertex, we're going to say negative b over 2a. All right, so let's recall, it said we can see here that a is going to equal to 1, b is going to equal to negative 7, and c equals 10. So to find the vertex, we're going to say x is going to equal negative b. Well, b is negative 7, and we're going to take the negative of it, 2 times 1. All right, so it's going to be a negative and negative makes it a positive, 7 over 2, which equals to 3.5. So for our vertex, the x is going to be 3.5. And then to find the y, we're just going to substitute that x back into the equation. So it would be 3.5 squared plus negative 7 times 3.5 plus 10. And when we add all that up, you end up with negative 2.25. All right, so now we have the y-intercept, we have the vertex, and now all we have to do is find the x-intercepts. How do we find the x-intercepts? Well, factor. That's the easiest way to do it first. So always think about factoring. Can you think of two numbers that multiply together to get positive 10, add together to get negative 7? Well, I know that negative 2 times negative 5 multiplied together gives me a positive 10, and it also added together gives me a negative 7. So I'm going to go ahead and graph or factor that out, x minus 2, x minus 5. All right, and so to find, if I set that equal to 0, I would know x minus 2 equals 0 or x minus 5 equals 0. So I know that my x-intercepts are going to be 2 and 5. So that's my last points. I'm going to say when y is 0, x is either going to be 2 or x is going to be 5. So now that I've gotten some points here, I can graph my parabola. And it says that y is going to be greater. All right, so to find out about y is going to be greater, let's just turn the page here. All right, so here's our graph, and step 2 just says to shade above the parabola because the solution consists of y values greater than those on the parabola. So we're going to shade inside for y is greater than. And one thing we can do to check is just choose a test point. And I'm going to go ahead and choose 1, 2, 3, 4. Let's choose 4. When x, let's choose this point, which would be xy, and that's going to be over 4 up 0. So let's try 4, 0 here. And going ahead and trying 4, 0, we're going to just plug that in for our x and y. And when we do, we see that 0 is greater than negative 2, and that is true, so we know we shaded in the correct place. All right. Here's another problem for us to try. Again, it says to graph this inequality. So the first thing I want to do to graph this is I'm going to remember that the boundary is going to be a solid curve. And I can find the y-intercept, and the y-intercept is going to be when x is 0, what is y? Negative 2. So there's going to be a point right here. And in order to find my vertex, I can just remember to say my vertex when x equals negative b over 2a. All right, so b is negative 5, and we're going to take negative of that. Over 2 times 2 is 4. So my x is going to be positive 5 over 4, which is equal to 1.25. They rounded it to 1.3. And when I fill that 1.3 back in place of my x's to find the y coordinate of it, so I have a 1.3. And when I fill this in, 1.3 squared minus 5 times 1.3 minus 2, put that in there, it ends up to be negative 5.1. So here's my point here. Now to go ahead and find the x-intercepts is a little more challenging. I'm not going to worry about that for right now. All I'm going to do to finish my graph is just go ahead and go halfway, recognize that this is my line of symmetry. And so I'm going to have another point on this side. And so now I can just draw my graph up this way and this way. Okay, so now that I have my graph drawn, then I can make a decision about shading. And it says that y is going to be greater. So my y is going to have to be greater. So we're going to shade inside. And there it is, okay? Because that's the places where y is getting larger, okay? My y's are getting larger. If I come down here, my y's are getting smaller, negative 6, negative 5, or negative 7. Okay, so my y's are getting smaller there. So I want to shade above the parabola because the solution consists of y values greater than those on the parabola. So here's my parabola and my y values that are greater than that for corresponding x values. All right, again, here's another one. You can choose a point inside there to just make sure. This example tried 2, 0, and you could just fill it in. And hopefully, when you do all the math, you see that 0 is greater than negative 4, which is true, so I shaded in the correct area, just choosing a test point. All right, here's another one we'll try. I'm just going to do these for you. They're a little bit tricky. Again, the first thing you want to do is graph it. This is going to have a dashed line because it's not included. It's not equal to. We're going to find that the y-intercept, so what is y when x is 0? We can see that y is going to be negative 7. So I can go ahead and graph 0, negative 7, which is right here. Now I need to know my vertex over here, so I'm going to say to find my vertex, I'm going to go ahead and say, remember, x equals negative b over 2a. And b is negative 6, so it's going to be negative 6 over 2 times 3. Negative 3 is actually negative 6. So negative 6 over negative 6 is 1, but we have to take the opposite of it, so that's 1. So when x is negative 1, we see that y will be 4. So there's my vertex. And then just using our laws of symmetry, we can see that I have another point right here. And now it says that y is going to be less than this parabola. Notice that my parabola is in dashed lines. And my y terms are going to have to be underneath here because that's where all the y's are getting smaller. So we're going to shade it down inside there. And then we could choose a test point to decide to just check this and make sure. And so test point we might choose would be -2, -10. We fill in all of our and do the math and see that -10 is less than -7, which is true, so we know we did the problem correctly. All right, just another little fact here. Quadratic inequalities in one variable, such as ax squared plus bx plus c is greater than 0, where a can't equal 0, have solutions in one variable that are just graphed on a number line. So if you don't have this, if this ends up being 0, not y, that means we just have one variable, which is x. Okay, and when we have that, we just graph it on a number line. All right, but we can still remember that it is a parabola, and we're going to be just choosing the points in between or outside of that parabola. All right, so for reading math, for and statements, both of the conditions must be true. For or statements, at least one of the conditions must be true. All right, so we'll see what that means. Okay, so another way to solve these problems is by using your graphing calculator. So in this example, it says to solve the inequality by using tables or graphs. So we're going to use the table in your calculator. First thing we want to do is go ahead and use your graphing calculator, and you're going to graph each side of the inequality. So we're going to graph this side, and then we're going to graph this side. So we're going to go to y1 or y equals on your calculator. Click y equals, and then you're going to enter this equation. And then for y2, we're going to say y2 is just going to equal 5, this part of our equation, all right? And then we're going to graph it, and so when we graph it, you should see something like this. This is going to be our y2, and this one over here is y1. Now, we are interested in finding out the values of x for when y1 is greater than y2. All right, so if you go ahead and look and type in second table, which is graph also on your calculator, it's the graph button, say second table, and you're going to see a graph that comes up, and we can see that from this portion, this is greater than 5, and here your y is also greater than 5. So we have two places that y is greater than 5. So you can see in your graph, when x is -7, y is greater than 5. When x is -6, y is greater than 5. When x is -5, y is greater than 5. So really, if this is -1, this is -2, -3, -4, and here's -5. So we can see that -5 on. So it's actually going to be written -infinity, comma, 5. And this is going to be greater than or equal to, so we're going to have a curved for our infinity and a straight line like that. And we're going to say, or y could be from -3, so we can look at our table over here. -3, so we're going to put another box like that, -3, all the way out to positive infinity. We're going to close it up like that. So that's actually going to be our solution. And here it is written a little bit more neatly. So you can see x is greater than -5, or x is less than or equal to -5, or x is greater than -3. And here's how it's written: -infinity to -5, or -3 to positive infinity. You can use this on a number line to show this. So we just plot x is less than -5 Notice that the arrow is going that way and our arrow is going this way. And we could also plot it this way. X is greater than, again, we have our arrow going that way, so our arrow is going that way, greater than -3. All right, here's another example. We're going to solve this inequality, again, using a table on your calculator. So first of all, get your calculator out. You're going to put in 1. Y1 is going to equal this equation, and Y2 is going to equal this equation. All right, almost the exact same. So when you do that, we see our graph. And this time it says we want the portion that's less than 5. So we just want this little portion here that's less than 5. And so to find that, we're going to find out, and we see that when x is -4, y is 4, and that is less than 5, but then it gets bigger on either side again. So it's only in one place when x is equal to -4, y is equal to 5. So let me show you how that's going to. So in this case, the parabola is below the line when x is greater than -5 and less than -3. So the solution set is -5 is less than x and x is less than -3. All right, so that's covering that -4 in there. So the number line shows the solution set. Here it goes. Okay, it's going to go. The solution set is that x is greater than -5, but less than -3. So it's just that tiny area in here. All right, from the -5 to the -3 that's included in our solution set. All right, here's another one you're going to solve. Use your graphing calculator to graph each side of the inequality. And when we do that, we see our graph that looks like this. All right, so we want to know when it's less than 7. So we're going to be looking down below here. All right, and so when you put it in the graphing calculator, we can see when it's less than. And it's only less than in this little section here from 0 to 1. Okay, so let's go ahead and see how that's written out exactly. All right. So the solution set is -1 is less than x, which is less than 2. Or it's just going from -1 to 2. And you could also draw a table, and here it is. And so that's the only solution that we can use because it has to be less than both of those. All right, in this example, we're going to solve the quadratic equation by using algebra. So first thing we're going to do is go ahead and set it equal to -3 instead of less than or equal to -3. We're just going to set this to equal here. All right, and then the next thing I want to do is go ahead and actually set it equal to 0. So I'm going to add 3 to both sides. So that's going to leave me with x squared minus 10x plus 21 is equal to 0. All right, so next I want to do is I want to factor this. Always remember, if you can, factor first. All right, so when I do this, I'm going to see what two numbers multiply together to get 21, add together to get -10. Well, I can see that that's going to be -3 times -7. So my factored form is x minus 3 times x minus 7 equals 0. So that's going to tell me some critical points here. All right, so on a number line, I'm going to just take a look here. I've got a number line here, and I see that x minus 3 has to equal 0, or x minus 7 equals 0. So I'm going to say x is going to equal 3, or x will equal 7. All right, so I'm going to put my 0 over here. I'm going to put a 3 here and a 7 here. All right, so I actually have 3 regions that I can be concerned with. I can be concerned with this region where x is less than 3. I can be concerned with this region right here. I'm going to make it in purple. There we go. And that is where x is, let's see, let's do it this way. 3 is less than x is greater than 3, but x is less than 7. And then I have my third region here. I'm going to be in this area where x is greater than 7. So I have 3 distinct regions here. And what I can do is I can just test some points inside each of these regions. So I'm going to choose a point in this region where it says x is less than 3. I'm going to try 0 for a point, for a test point. All right, so when x is 0, so I'm going to fill in back into my original equation up here. I'm going to choose the point 0. So that's going to be 0 minus 0 plus 18 is less than or equal to negative 3. Is 18 less than or equal to negative 3? No, so this is not a solution. All right, the next thing I'm going to do is try another point inside my purple solution. Okay, so inside this area here, I think I'll pick the number, I'm going to go ahead and pick 4 because that's the smallest, easiest one that I could choose. So 4 squared is 16 minus 40 plus 18. All right, so let's see, 16 plus 18. Let's just do that right quick. 6 and 8 is 14. Yeah, 14. Oh, 34. Okay, so 34 plus a negative 40 is equal to negative 6. Is that less than or equal to negative 3? Negative 6 is indeed less than negative 3. So I know that this area is true. My purple area was true. So I'm going to put a check by this. I'm going to go ahead and put a minus on this one because that didn't work. So now I'm going to choose a number greater than 7. So I'll just choose, I'll choose 8. A number on the outside one. I'm going to choose 8, and we did that in yellow. So this is 8 and 8 is 64 minus 80 plus 18. All right, plus 18. So let's see, 64 plus 18. 8 and 4 is 12. 6, 7, 82. 82 minus 80 is equal to 2. Is 2 less than or equal to negative 3? No, it's not, so that's going to be a minus. So I know that my solution region is going to be this region. 3 is less than x, which is less than 7. That's going to be my solution region. And actually, it's going to be the equal to signs in here also. All right, here it is on the next page, written out a little bit more beautiful. So we find our critical values by factoring. We find out that x is going to equal either 3 or x equals 7. All right, and so here's my 3 regions I showed you before. X is either less than or equal to 3. And then we had this purple region over here, and then I had my yellow region over here, and actually this region was green. Okay, so now I have my 3 regions. And I'm going to test interval values in each one. They chose 2, 4, and 8, and I chose 0. But either way, it's still going to work. So when you try 2, it doesn't work. When you try 4 inside this middle region, it does work. And when they tried 8, again, it does not work. So what that tells us is that our solution region is going to be right in here, and so it's this is our solution region that was true. So we could also write it in this we could also write it like that. All right, so here's another one for you to try. Turn your video off and see if you can do this one on your own. All right, so for this one, we're going to, first of all, to solve this one, we're going to go ahead and write the related equation. And so here it is. I changed it from greater than and equal to just equal to 2. And the next thing I'm going to do is go ahead and subtract 2 from both sides. So I'm going to rewrite my equation to say x squared minus 6x plus 8 equals 0. Now I'm going to factor this out. And so I want to find out two numbers that multiply together to get 8, add together to get -6. Well, I know that could be -4 times -2. All right, they multiply together to get +8, add together to get -6. So I have x minus 4 times x minus 2 equals 0. So either x minus 4 has to equal 0 or x minus 2 has to equal 0. So x is going to equal 4 and x is going to equal 2. All right, so there's my critical points. So we're going to take our number line, all right, and we're going to put our critical points in there. I know that I have a 2 and I have a 4. All right, so I'm going to have 3 regions that are going to be covered. I'm going to start for this first region over here, and that's going to say x is less than 2. I have another region, this middle region right here, and this one we're going to say 2 is not greater than. X is, I always say it the other way though, x has got to be greater than 2 and less than 4. And then my third region is going to be out here, and this region is where x is greater than 4. All right, so there I have 3 different regions. Now I'm going to choose a point in each region and see whether it's true or not. So this is 2, so I'm going to go ahead and try a 0. Okay, that's just a test point. So I'm going to fill in 0. 0 minus 0 is 10. Is 10 greater than or equal to 2? Yes, it is. So that we'll put a check there. Okay, the next place we want to do is the middle region in blue. So let's choose a point in here. Let's choose the point 3. All right, so 3 squared is 9 minus 18 plus 10. 9 minus 18 is -9. -9 plus 10 is 1. Is 1 greater than or equal to 2? No, it is not. That is not true. So we'll put an X in there. And finally, we're going to test X is greater than 4. So let's choose 5. So again, I'm going to go ahead and put my points in. 5 squared is 25 minus 30 plus 10. Okay, 25 minus 30 is -5 plus 10 is +5. Is +5 greater than or equal to 2? Yes, it is. So now I can see where my 2 regions are when x is less than 2 and when x is greater than 4. So my region is going to be x is less than 2, or, and remember the or goes like this, x is greater than 4. All right, now I'm going to just kind of speed through it really fast on the next page the way the book has it nice and neat and orderly, but you can see it again. You can slow down the video if you need to. So here's the solving of what we just did. First of all, write it in standard form, then factor it out. Using the 0 product, we see x equals 2 or x equals 4. So we divide it into our 3 regions. Remember, I had a x is less than 2, or x is greater than or equal to 2 and less than and equal to 4, and then x is greater than 4. Okay, so those were the 3 regions that we divided it into. So then you could do a test x value in each interval. So here are my intervals here. I've got an interval here, and an interval here, and an interval in here. So we tested the points in each of those. I tested 0, they tested 1, but we still see that that's true. So you can put a check there. For the middle, they tested 3, and so you put a check in the X in there, and then the last one 5, and that one turns out to be true. All right, so now that we know that, we can shade in the correct areas, which are right here. So the solution is right here. All right, so try this one on your own. It's going to take all the different pieces of information that you've learned and kind of put them all together. So turn your video off and give it a try. All right, so So the first thing we want to do is go ahead and rewrite our related equation. And then I'm going to say minus 2 from both sides. So I end up with negative 2x squared plus 3x plus 5 equals 0. Now I can't just factor, I need to factor it out, but I need to be careful here because I have a negative 2 in my coefficient with my x squared, and I don't really like to have that. So I'm going to have to do a few things that change things up. So I'm going to say I'm going to find two numbers that multiply together to get negative 10, because that's 2 times 5, and add together to get 3, my middle term. All right, well, I happen to know that would be 5 times 2, and the 5 has to be positive because my 3 is positive. So I'm just going to rewrite this 3x to make that be the same as negative 2x plus 5x. And then I'm going to bring everything else down. And I'm going to bring this down, negative 2x squared. All right, now I'm going to group these together, and I'm going to group these together so that I look at this and I see I can factor out a negative 2x, and that's going to leave me with an x plus 1. And on this side, I can factor out a 5, and that will also leave me with an x plus 1. All right, and this is all equal to 0. So I can see that I can actually factor out an x plus 1 out of both of that. So x plus 1, when I factor that out, all that I have left is negative 2x plus 5, and that equals 0. So I know that either x plus 5 equals 0, or I know that 2x, negative 2x plus 5 equals 0. So I'm going to subtract 5 from both sides, so x equals negative 5. Or, let's see, subtract 5 from both sides over here. So I have negative 2x equals negative 5. Divide both sides by negative 2. So x equals 5 over 2, which is 2.5. All right. So now that I know that, I have my critical points, negative 5 and 2.5. So I'm going to draw my line. And I'm going to have an x at negative 5 and an x at 2.5. All right, so I have divided my number line into 3 separate regions. I have one region here, so it's going to say x is less than negative 5. I have a region here, which is going to say negative 5 is less than x, which is less than 2.5. And then I'm going to have my third region over here, which says x is greater than 2.5. Okay, so now I'm just going to choose some points in here that I can use to fill in. I need to choose a point in this green area. This is negative 5. So I guess I'm going to choose, I'm going to actually choose negative 10. It might be a mistake, but I'm going to choose negative 10 because that's easy. So 10 times 10 is 100, times 2 is going to be negative 200 plus negative 30, because negative 10 times 3 is negative 30, plus 7. So this is going to be, and we want that to be less than 2. So negative 200 plus negative 30 is negative 230 plus 7 is negative 227, or 23 actually, is less than 2, and that is true. So we're going to put a check there. All right, in the purple region, I'm going to choose 0. That'll be a nice, easy one. And so 0 squared, 0 plus 0 plus 7. So is 7 less than 2? No, it's not. 7 is a lot less than 2. So this one gets a big X. And we can probably guess now. Let's choose 3 in here. So we're going to fill in again, and we're going to hope it's true. 3 squared is 9 times 2. Negative 2 is negative 18. Plus 9 equals negative 18 plus 7. Negative 18 plus 7 is negative 11. Is less than 2. That is true. So we get a check there. So again, we can see that my answers that are true are x has to be less than -5 and x has to be greater than 2.5. So we can rewrite our final answer to say x must be less than -5, or, this is the sign for an or, x is going to be greater than 2.5. All right. Another way we could do this is just say -5 comma 2.5 and put it in parentheses, and that's our solution set too. It could be written that way. All right, so I hope that was helpful. Here it is, written a little bit faster. They factored it out. Find your x's for your critical points. Here's our critical values, just like what we did a minute ago. And then we do test intervals. And each time you test it, they tested -2 was true. X being 1 was not true. And then when x was equal to 3, it was true. So your final answer is going to be set up like this. And we see that the solution is x equals -1 and x is greater than 2.5. And that is the end of this lesson. Be sure and check out your book for the more examples on page 366 to page 369 if you have any other questions or need help doing your assignment. All right, you guys have a great day, and I'll see you in class. Bye.